Now the procedure, a step-by-step procedure to perform a one-way ANOVA analysis of variance. So the first step in doing this is state the null and alternate hypothesis, then collect the data and calculate the mean and variance of each group. Then the most important step comes, third one, calculate the between group variance. We call it as sum of squares between SSB, or within group variance, SSW, sum of squares within. So the total variance sum of squares total SST. So you have to calculate these three things. Once this is done, for to calculate the F statistic by dividing between group variance by the within group variance. Then determine the p-value associated with the F statistic using a table or statistical software. Then final, compare the p-value to the significance level alpha and make a decision regarding the null hypothesis. So now let's do an example. So ANOVA, an example that we're going to do here, an example is let's study comparing the effectiveness of three different types of fertilizers on plant growth. So that's what they want to do. So in this study, let's write down the steps one by one. So step one, let's make it our null hypothesis first. So H0 null hypothesis is it would be there is no significant difference in plant growth between the three types of fertilizer. That's what is our null hypothesis. There is no difference. There is no significant difference in plant growth between the three types of fertilizers. So this is our null hypothesis, and alternative hypothesis would be there is a significant difference. That's what the alternate hypothesis. The first step is done. Let's move ahead. Step 2. Now to perform ANOVA, we have to take a sample of plants would be grown using the type using each type of fertilizer, and then the heights of the plants would be measured after a certain period of time, obviously. Then we will calculate the mean variance. So the mean and variance of the plant heights would be calculated for each group. It's nothing but the fertilizer type, with each fertilizer type. Then let's calculate the most important parameters. Step 3, let's the between group variance would be calculated as SB, that's between the groups, and SSW, that is within the groups, within the group. So the between group variance would be calculated as a sum of the squared differences between the group means and the overall means of all plants. That's what is your SSB. So SSB is nothing but it's the sum of the squared differences between the group means and the overall mean, that's the data set mean of all plants. And SSW is equal to the within group variance would be calculated as the sum of the squared differences between each plant's height and the mean height of its respective group. That's it. So then you can calculate the total variance SST. It's sum of SSB plus SSW. So SST would be calculated as the sum of the squared differences between each plant's height and the overall mean height. That's the total variance. Total variance would be calculated. Let me put it into the proper way. Total variance would be calculated as the sum of the squared differences between each plant's height and the overall mean height. So total we have SSB, SSW, SST. SSB is sum of the squared differences between the group means and the total overall mean of all plants. And SSW is sum of the squared differences between each plant's height and the mean height of its respective group. And SST is sum of the squares of total sum of the squared differences between each plant's height and then overall mean height. So with this, we will have all three parameters: SSB, SSW, SST. Now, it's pretty straightforward. Step 4, the F statistic. Calculate the F statistic. So, this F statistic is equal to, it would be calculated by dividing the between group variance. So between group variance SSB divided by SSW. So the F statistic would then be calculated by dividing the between group variance by the within group variance. So once you got this, it's time to calculate the p-value. So step 5 is to determine the p-value. So the p-value associated with the F statistic would be determined using a table, F statistic table or statistical software. That's it. If the obviously final step, conclusion or inferences, if the p-value is less than significance level, that's alpha is nothing but 0.05. If it is less than the significance level, then we're pretty straightforward. What will we do? What will we do? We will, the null hypothesis would be rejected, and it would be connected, it would be concluded that there is a significant difference in plant growth between the three types of fertilizers. If the p-value is greater than alpha, the null hypothesis would not be rejected. We are failed to reject the null hypothesis, and it would be concluded that there is not enough evidence to suggest a difference in plant growth between the types of fertilizers. Now let us put this into the code format so that we can prove it. Okay, so SciPy stats has been imported, and fertilizer 1, this is the fertilizer 1 data. So here you got same amount of plants with the 4 centimeter, 5 centimeter, 6 centimeters of height. With the fertilizer 2, the heights were 5 centimeter, 6 centimeter, 7 centimeter, 6, and then 5, 7. And with the fertilizer 3, 7, 8, 6, 7, 9, 8, and you can easily calculate the mean for each fertilizer. Now let's directly put it into the ANOVA. So calculate the ANOVA. So what all we want? F value, first one, F value, and then P value. So these are the two we want, nothing else. So stats, from the stats I'm gonna call up F underscore one way method. We are doing one way ANOVA. Then all fertilizer 1, fertilizer 2, fertilizer 3. That's it. So now let's print the results. So print F value and also print P value. And here it is. Our F value is 13.04. Pretty strong, pretty high significance, pretty high or large F statistic. Our F statistic is large. If F statistic is large, what does it mean? It does mean that there is a clear-cut difference. There is a clear-cut difference in plant heights between the groups. That's what the F value is saying. Now let's take the P value and compare with this. Okay, let's take P value. So what's the condition? P value is lesser than P value is lesser than 0.05 or not. Let's check. It's true. It's lesser than 0.05. It's lesser than significance level. Then what does it mean? It's pretty straightforward. The null hypothesis would be rejected, and it would be concluded that there is a significant difference in plant growth between the three types of fertilizers, and that's what the conclusion of above statistical analysis. This is what the conclusion.